All right. We're going to do permutations and combinations. This is on 6B, which is the back of worksheet 6 in your packet. This is where we left off from yesterday. So permutation, you want to think the word priority for permutation. This is when order, just a second, I just want to get in my page so I have all my stuff in front of me. I have to pause. Got off my track here. What page is this? 6. I've changed the numbers around. That's why I'm getting myself together here first. Oh, there it is. Okay. The order, when you're the priority of the order, priority would stand for where order matters. Okay. So if the order would matter if you were placing first, second, or third in a race. The order matters, meaning you're only going to have one person to select from. You have a certain number of people in the race. The first person who gets first place, they're out of it for second place, right? They're not going to come in second. So order matters for a permutation. Pardon? There's a formula, NPR, and it is n factorial divided by n minus r factorial. Now, what does factorial mean? Well, I don't want to give you a formal definition, so I'll just explain it by giving you a concrete example. 5 factorial is equal to 5 times 4 times 3 times 2 times 1. That's what it is. So if you had 35 factorial, it's 35 times 34 times 33 times, it's a big number. So for the formula for permutation, it's the n stands for the number of objects or items. I can't, my pen, I'm going to have a little trouble with this pen today. It's not been very smooth going. Number of objects or whatever. And R is how many at a time. P stands for permutation. How many at a time? Okay, and then a combination formula is similar, except there's a little bit of a difference, of course. Combination is when order doesn't matter. So an example of that, a committee. If you're picking people to be on a committee, does it matter who you pick first, second, or third? If you want 4 people, first, second, third, or fourth, it doesn't matter what order, okay? The order doesn't matter. All right, the formula for a, we need to know also before I go on with that 0 factorial is 1. 0 factorial is 1. So nothing factorial is 0. That makes sense? All right. The formula for a combination is n. This is how the formula looks in your calculator, and I'm going to show you it sometime soon. This formula is the same as the last one, except n factorial divided by n minus r factorial times r factorial. So let's try using it. First, we got to decide if you need a permutation or a combination. And some problems will be able to be done not even using the formulas, but I want to show you how they work. You make sure our phones are put away, please. Thanks. Okay. You didn't what? Know how to spell? Oh, I have it spelled correctly, right? Oh, what did I do? Is it confirmed? Is it 2 T's and 2 E's? Wow, it has lots of triple letters. I'll add an M in there. I think you're right, committee. I usually spell well, so I'm sorry. I'm usually not a poor speller. Okay, you have 32 people in class. You're choosing a team of 3 people. How many possible ways can you choose them? Would order matter? Does it matter because you're just choosing a team of 3? Order you pick the people. You just need 3 people. Does the order matter? No. Okay, so it doesn't matter. So this is a combination. It's like a committee. Okay. Order does not matter. Okay, here's what I mean by that. Maybe you're not sure what I mean. So let me explain it another way. The reason the order doesn't matter is who's on the committee isn't going to change by how you pick those 3 people. That makes better sense? Okay, if you're trying to do places in someone winning first, second, and third, then order's going to matter. Who gets which one matters, right? So this one, order doesn't matter, so we're going to do the combination. So how many do we have to choose from? No, 32. The number of choosings are going to be 3. There are 3 people we're going to choose. So that's 32C3, which would be 32 factorial divided by 32 minus 3 factorial times 3 factorial. Now, this one time, I'm going to show you how to do this without the calculator. So think about it. 32 minus 3 is how much? All right, so that simplifies to 29 factorial. If 32 factorial means 32 times 31 times 30 times 29 times 28, 27, then couldn't we rewrite this as 32 times 31 times 30 times 29 factorial? Okay, now on the bottom, we have 29 factorial times 3 factorial. So what could I cancel? The 29 factorial, because they would be, if you expanded it out, you'd have 29 all the way down to 1, all those numbers multiplied, and you'd have that on the bottom too, so it's nice to cancel that out and reduce. So now I'm going to calculate what 32 times 31 times 30 is divided by 3 factorial, which is 3 times 2 times 1. All right, so on your calculator, type this. 32 times 31 times 30 divided by 3 times 2 times 1 would be 6. Oh, I'll show you in a minute. I'm not there yet. I'm doing it once without it because we didn't always have these calculators. I need you to know what factorial means. 4,960. That should be your answer. Okay, how many ways? 4,960 ways. How many ways can 8 students be placed in a line? Does the order you get put in line matter? All right, we have to decide if it's a permutation or a combination. It's a permutation because the order matters. You can't go first and second. You have to go first or second, right? When you pick a committee, does it matter who you pick first? You still have, okay. No, is the committee going to change based on the order you pick them? No, the committee is still the committee. The order of the people in line, excuse me, the order of the people in line would change the order of the people in line. Okay, so this is a permutation. There are going to be more ways to do it. So let's go 8. All right, so how many people are we lining up? Everybody. So it's 8P8. Or you can do this without the formula, guys. Why? Because how many people do you have to line up? 8. The first person, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That's the choices for each different position. Okay, that is 8 factorial. Or if you use the formula, let me show you how. If you're going to take all of the people and put them in the formula, because the R value is also 8, and so is the N, it would be 8 factorial divided by 8 minus 8 factorial. And 8 minus 8 is 0. 0 factorial is 1. That's why we needed to know that. Okay, why is it 1? It is. I don't want to proof it. Okay, so let's go, and I'll show you where the factorial button is. All right, so if you go and you put in 8, and you want it to be 8 factorial, you hit Math, arrow over to Probability, P-R-O-B, Math, and then arrow over to the Probability, P-R-O-B. Choice 4 is 8 factorials. That's 40,320. Now I'll show you how to type 8P8. 8 permutations of 8 choices under the probability. You see it? It is choice 2, NPR. The combinations is choice 3. So I am going to hit 2, and then it tells you to put in the R factor. How many of those 8 people are you choosing? Okay, so both of these have the same answer. All right, so basically a permutation of the number being 8 people or the amount of things, and you're going to use them all, is simply the counting principle. Okay, this is a big one. What was it? I forgot. 40,320 ways. And how many ways can you choose a group, choose a committee of 4 boys and 4 girls if there are 20 boys and 15 girls to choose from? Well, we have to multiply the 2 situations. Does the order matter if you're choosing 4 girls? No. Does it matter if you're choosing 4 boys? No. The order does not matter. So it's a combination. We have 2 combinations, though. We have 20 boys, so we're going to take 4 of them. So the N is 20 and the R is 4. And we're going to multiply that times the girls that we need to choose, 15 girls to choose from, and we're taking 4. So we're just going to type this in the calculator as opposed to doing it all out with the formula. So type 20, and then press your button for math, arrow to probability, press 3, and then put in how many girls or boys were taken, which was 4. Now, careful, we're still in the subscript right now. So if you have one of the newer operating systems, you need to arrow to the right to get out of there. And then you can hit times 15, math, probability, choice 3, and we want 4 of those girls. So it's 6 million. 613,425. That's how many ways. Crazy, huh? Now, I thought the next one was interesting. We talked about this one last hour, and we had two different ideas. Yes. It's the same. Oh, you mean you have to put the number, you just have to enter the number after you get you enter the first number, you hit go to the math key and find that which one you're using, and then you enter the second number. I'm pretty darn sure. Okay, we try it again, please, so you know. Otherwise, I'll have to come show you. All right, and how many ways can I arrange my videos and DVDs on my shelf if I have 5 videos and 7 DVDs, and all the videos are together, and all the DVDs are together? Disorder. Order matters is a permutation. Got it? Okay. So, how many? We're going to put in 5 videos, and we're doing them all. 5p5 times 7p7. Now, my last class said, well, Miss Heimer, does it matter if you put the DVDs first or the videos first? Well, it would be the same answer, but we thought, well, maybe we better multiply by 2. And this is the first year that anybody has ever suggested that. And I didn't really think about it myself. I was just quick calculating it, you know, and I did that. I think they're right. Because if the videos are first to DVDs, and then you flap it, isn't that a whole nother set of this amount? I thought that was pretty cool. All right. Not that I'm going to try to trick you on a test or quiz. And all right, same process. Matt, are you getting that now? Okay, cool. All right, choice 2, as I'm having trouble thinking if you're talking. All right, times 7. Oh no. Guess where I put the 7. All right, so how can I fix that? Second enter. Back up. I got to get that out of there. Because I typed it wrong. I needed to get out of here and then hit times 2. Now, that doesn't happen on that calculator, Matt, or the ones that are in the back that you're allowed to borrow. All right, so it was a lot. 1,209,600. I lost my numbers. What was here? 1,200,000 and what? There we go. Okay, we need to go to talk some more about odds and on 9. Okay, I need a little less chatting, please, so I can be focused on what I need to say to you guys. We already talked about probability. You want to close the door, please? Thank you very much, Anthony. Number of favorable outcomes over number of all possible is your probability. Odds are different. Odds are favorable over unfavorable. So if you have odds, if you add the first number and the second number, you get the total that happens. Have you ever heard of a horse race being the odds are 2-1? It's really out of 3. The probability is 2 out of 3. Then, if the odds are 2-1, it's like it's in thirds. There are 3 parts that they're considering. So it's almost like saying 66% chance because the third is 33%. Well, 33 and a third percent. 2 to every 1. So twice as many. Is that what you're saying? Okay. So let's check this out. We got the probability of each outcome of a die is rolled. All right, we're going to find the probability, then we're going to do some odds. We'll do really fast on these. The probability of rolling a 2 would be 1 out of 6. That's probability. Probability of a number less than 4, there's 3 of them, 3 out of 6 or 1 out of 2. The number being greater than 2, 2 or greater, 5 out of 6. A number greater than 5, there's only one of them. 1 out of 6. Now, find the odds of each outcome if a die is rolled. A multiple of 2. Odds. There are 3 out of the 3 that are a multiple of 2. There are also 3 that are not a multiple of 2. It's 3 to 3 or 1 to 1. Reduce it to 1 to 1. A number greater than 2. There are 4 numbers that are bigger than 2. There are 2 numbers that are not bigger than 2. So it's 4 to 2 or 2 to 1. My pen's stuck. An even number. There are 3 to 3, 1 to 1. Odds. A number less than 3. 2 numbers less than 3, 4 that are not less than 3. So that's 1, 2, 2. There's our deck of cards again to remind you about cards. There are 52 cards in a deck. Half of them are black and half of them are red. There aren't any jokers in the deck, truly. That's just the extra cards that are used for some fancy games. I don't know what they're. There are 13 in every suit. What's the probability of selecting a spade? 13 cards out of 52 cards are spades, or there is 1 in 4. That reduces 1/4. Or just think about it, there's 4 suits, 1 in 4 is a spade. What's the probability of selecting a red jack? Well, there are only 2 red jacks out of 52 cards. Reduce that to 1 to 26. Now, what are the odds of selecting a heart? Odds. 13 hearts. 39. And then you reduce this to 1 in 3. 1 to 3 odds. What are the odds of selecting a black 6? There are 2 black 6s. How many cards are left after you pick the 2 black 6s? 50 cards left. So reducing that is 1 to 25. What's the probability of selecting a heart or a queen? How many hearts are there? 13 hearts. How many other queens are there that you haven't chosen? Okay. If you take all the hearts, you've taken the heart queen out. So there's 13 hearts plus 3 more queens, a diamond and two black ones. Spade and a club. I've accounted for the overlap. Okay, so I've got 16 cards used up. You 52 minus 16, so you can get your, oh, this is probability, excuse me, 16 to 52. Now I need to reduce that. You can divide by 4, it's 4 to 13. And I can write that as a fraction or with a colon. Probability. Yeah, that's fine. Well, I didn't have much room, so I wrote them. You can write them. Sorry, I didn't mean to make you think I was doing odds. I'll fix it. They can be written. Both of them can be written either way. We usually write our probabilities as fractions. Odds, you see these often, but they can be written as fractions also. Oh, yes, it matters big time. Yeah, it's totally wrong backwards. Because you're saying that this many are the hearts. This many are not hearts. This is yes, this is no. What are the odds of selecting a black 6? How many black 6s are there? Oh, we already did that one. I'm sorry. I don't know why these are repeated. We're actually on 14 then, aren't we? What are the odds of selecting a red card? Half of them are red. Half of them are not red. It's 1 to 1. And what are the odds of selecting a black card or an 8? Okay, there are 26 black cards. Half the deck. Plus there are 2 more that are 8s that are red. So it's 28 to 24. And then I reduce that to 7 to 6. Okay, I am not doing all of the problems. I'll let you mess with the marbles problems. And then I'm going to jump over here to this back side of 9 on 9B. I wanted to do a couple of these with you because they're a little worded a little different. So let's look at 24 together. If the probability that an event will occur, okay, really, guys, it's been really obnoxious today. If the probability of that an event will occur is 3 to 7, what are the odds that the event will occur? All right, now, probability is 3 to 7. That means 3 out of are favorable. And I want the favorable amount, but I want it compared to the not favorable. So probability, this is the total. So 7 minus 3 is 4. So the odds would be 3 to 4. So you have to be able to go from probabilities to odds, or vice versa. All right, I did an example of that. Let's go to, well, 20, what the heck, let's do 25. If the probability that event will occur is 2 to 5, 2 is it will happen, 5 is the total. That means 3, because what are the odds that the event will not occur? So if 2 out of 5 times it does occur, how many times will it not? Okay, this is why we need to focus. What are the odds the event will not occur? 3 times to the total was 5, so 3 to 2 for not occurring. It will occur 2 out of 5 times. So that means it doesn't occur 3 out of 5 times, right? Odds would be 3 to 2 then, that it does not occur. Okay, let's try 27. If the odds that an event does not occur are 5 to 7, what is the probability that the event does occur? Not is 5. Does then is, since this is at odds, what's the total though, guys? 12. All right, so our probability is going to have 12 on the bottom. As the odds that it does not occur are 5 to 7. That means this is the second part is the does occur. And the odds were that it does not occur. This would be that it does not occur. Does that make sense now? The odds the event does not occur. Not is the top number. Does is the bottom. So what is the probability the event does occur would be 7 out of 12. Or 7 to 12 if you want to write it that way. The other one I wanted to do with you, which one? 29? Okay. I can get my turn. All right, 29, I've been asked. If the odds that an event will occur are 1 to 3, what are the odds that the event will not occur? Just reverse it. 3 to 1. Oh, let's look at 31. What are the possible ranges for values of probability? Yep. 0, it either doesn't happen to anywhere in between that, and it always happens. So that'd be 0 to 1. 1 would be 100% of the time. 0 doesn't happen. Now, what about odds? Could have no chance of something, right? No, 0 odds. But it could get really big. Have you ever heard 1,000,000 to 1? Mm-hmm. It is 0 to infinity. Good thoughts, Madison. They don't know who you are. I'm sorry. Okay, I won't say your name. Anonymous. I'll delete it. All right, there was one more I wanted to do with you guys. And that was the last one on the page. It's been a while since we did a chemical problem. Mixture. Are you doing today in science? Chemistry? Do you do these things? All right, well, anyway. We have a column for percent. We're going to do a column for the amount, and then we have a total column. All right, let's see what we got. A chemist is making 400 gallons of a solution that's 48% alcohol. Okay, this is what they want to make. That's the end result. What is she going to put together? She has one solution that's 40% alcohol and another that's 60. We're going to take those two and mix them. She wants to end up with the 48% solution. So let's see. She's wants exactly 400 gallons of the solution in the end. So that's going to be the amount column. How am I going to write the other two amounts that we have to figure out? It says how much of each should she mix to get exactly 400 gallons? I can't use two variables, so I got to pick one of these to be x. Why don't you tell me? This one? Okay. X amount, and how am I going to write this in terms of x and 400? Well, I can't assume anything. Say that again, Zach? There you go, 400 minus x. Okay, multiply across 40x is equal to 60 times 400 minus x. And the bottom product is 48 times 400. And what we're doing is we're mixing the two lower concentration, or what, the two in betweens, the low one and the high one, to get the mixture that is a mid concentration. So we got 40x plus, and I'm going to go ahead and distribute now, 24,000 minus 60x equals 48 times 400, and that's, let's see, 192, 19,200. I just did 4 times 48 in my head and then added a couple zeros. All right, 40x minus 60x is negative 20x. And then we need to subtract 24,000. Oops, too many zeros. 19,000, whatever that number is. I can't even read. 19,200 minus 24,000, and we're going to end up with a negative. And that's a good thing since we have a negative 20x. Can someone tell me what that is? Just so I don't have to. 4,800? Yeah, you're right. And divide that, it's negative 4,800. So we got to divide that by negative 20. Okay, so x is 240. Now you have to answer the question. So we need 240 gallons of 40%. And good, yes, thank you, Anthony. 160 gallons of 60%. To back up just 1 second, I think we might want to do some totals on these when you're trying to do this problem. There are, I'll just tell you, if you add these up, 1, 2, 80, 380, 480, 500 males. And then how many females? I think that's, thank you, 535. That might help you with those questions. And then if you wanted to know the total number of kids in all, it's 1,035. That should help with those questions. All right, so your assignment, your worksheet 10 and 11, and then we're also going to want to get working on 82, 83. It says it's worksheet 7. It says 82 and 83 on it. We'll spend some time asking questions and working on Monday, but don't expect to have enough time to do everything in class. So you're going to need to have do some homework. So please do as much as you can, and then think what you would like to ask me on Monday. Have a nice weekend.